So in this question, we have a graph to start off. We'll use our Oy-Zerga to analyze the graph. So OYXRGA. The origin is here. So that's 0. And this is the x-axis. So that's the origin. Y-axis is position in meters. X-axis is time in seconds, normal units. So therefore, any questions asking about the axes would be position and time. So any question about position and time, we'll just read the graph. The slope is delta x over delta t, which is the velocity. So any question asking about velocity would be about the slope. And the area is x delta t, meter seconds, which has no significance at all. So now the question, they're moving in opposite directions. The position is shown. What is the speed of the center of mass? So we're looking for the speed, the slope of the center of mass of the two-car system. So the cars are identical, and we know the center of mass is x1m1 plus x2m2 all over m1 plus m2. So if we were to take the last, for example, the last point and figure out at time 1 where the center of mass was, well, we would have a position of 30 times m plus the other position, which is minus 10 times m, and the mass is 2m. So that gives us 20m over 2m, which is 10. So the center of mass is right here. And that should stand to reason. They both have the same mass. So if they both have the same mass, the center of mass would be between them. So this line plots, this blue line plots the location of the center of the mass. Well, the slope is 0. So the velocity is 0. And that makes sense. After 0.5 seconds, this one moves 10 meters away. And after 0.5 seconds, that one moves 10 meters away. So what we're seeing is at all instants in time, the mass is moving an equal distance away. So the center of mass here, now depicted in gray, is that center line, the velocity 0. The next question we have is position time graph. So again, we'll do our Oy-Zerga. The origin's right there since there's no numbers. Y-axis position, no units are given. X-axis time, no units are given. So we can read the axes, position and time. The slope is dividing the axes, which is the velocity, and the area we just saw in the previous question is nothing. So we're shown the position of time moving along a straight line is shown in the graph. So we have a straight line like this, and we're starting at some, if this is the 0 point, it's starting at some value over here. And what this shows is it moving in this direction and then moving in this direction. This is for object 1, moving back and forth. Oh, it never goes past 0. It stays in the positive, moves back and forth kind of like this. And the other one is starting at 0 and moving at a constant speed like this. So this one is moving along. It's constant speed because the slope is constant. Moving along like this all the while. The red one is starts here and moves like this and back and forth and all of that. So there's some crazy stuff happening. So now if we read the question, what's true about the distances the two objects have traveled at time tf? Well, at tf, the distance that object 2 has traveled is this distance right here. So it has this value right here, which we will call x. Now, the other one has traveled this distance and going in that direction, and it travels the same distance again going in that direction. And then it travels this distance getting to there, and then it travels this distance and getting to there, and then it travels that distance and getting to there, and then that distance again. So if you take a look at these different heights, this one and 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 this one, these all add up to far more than the x. Object 1 has traveled a lot farther. So let's see what they say. Object 1 has traveled a greater distance. Looks right. 2, that's the opposite. Same distance, false. Cannot be compared using the graph, and that's false because we can get the distances. So it's choice A. And the next question, do the two objects have the same velocity? Well, velocity is the slope. The velocity is the slope. So let's clean this out. Now, what we know about object 2 is it has the same slope at every instant in time. So we're looking for a slope on the other graph that is similar to it. So let's look at our choices for how we can TA, TB, TC, and TD. So let's look at TA. TA is here, and the slope right there is about like that. So that does not match the slope of object 2. TB definitely does not match the slope. TC, if we look at TC, that line looks parallel to this. So it looks like TC, and TD looks like that. So the answer is TC. Question 4. A block is projected up a frictionless inclined plane with speed v0. Plane is inclined 30 degrees above the horizontal. What is the acceleration of the block at the instant it reaches its highest point? Well, what we know is that the acceleration, which is caused by gravity, is going to be the same the entire time. All right? It's going to be the same the entire time. And we know that the greatest acceleration we could ever experience being caused by gravity would be if it were just dropped, and that would be 10 meters per second squared. But because this is the angle, it's at an angle, we know it's going to be less. Because if we made this angle less, it would not speed up as quickly or slow down as quickly, and the bigger we make the angle, the closer it'll approximate 10. But it can't be 10. So we know it's not 10 meters down, it's not 10 meters up. Said it cannot be calculated. Or 0. Is the acceleration 0? Well, acceleration of 0 means the speed, it will not slow down. And of course this thing will slow down if you sign it up. So it can't be 0. So now it comes down to it can't be determined, or it's 5 meters per second down the inclined plane. Let's check the direction first. Even though it's moving up the inclined plane, it will be slowing because the acceleration is down the inclined plane. So that's true. Can it be determined? Well, we know the acceleration is 10 meters per second straight down. And that acceleration straight down the inclined plane could be broken into its two components. And of course, we know this angle that I'm drawing here is 30 degrees. And this is the hypotenuse. This is the opposite of 30, and this is the adjacent. So sine of 30 would equal the opposite side, which is the acceleration parallel to the plane, divided by the hypotenuse, which is 10. So 10 sine 30 is the acceleration parallel. Now, we can whip out our calculators, or we can just remember the sine of 30 is 0.5. That's a good one to know, and it comes up an awful lot. So the acceleration parallel is 5 meters per second squared. That's why it's choice B. And so, of course, it can be calculated, so that's eliminated. Question 5. All right, we have a VT graph. We'll do our Oy-Zerga first. OYXRGA. We'll look for our origin, and we see the origin is right there. So this is the 0 point. So these are the negative values we see, and those are the positive values. So the origin. The y-axis is velocity in centimeters per second. We want to be careful of that. Centimeters per second. The normal x-axis units are in time. So therefore, any questions about velocity time, we would just read off the graph. Those are the axes. The gradient, delta v over delta t, is the acceleration. And the area is v delta t, which has units of meters per second times seconds, which is meters. So the area is the displacement. So if the question's asking about displacement, it's area. If it's about acceleration, it's the slope. And if it's about velocity or time, we're just going to read it off. Sets an object, spring in oscillatory motion. To record the velocity, the acceleration of the object at t7 is most nearly equal to, well, acceleration is the slope. So if we go to 0.7 seconds, it's going to be the slope there. And we know whenever there's a curve, we're going to draw a tangent to the curve at that point in time, and that should be the slope. Let's look at our choices. The value of the graph. Well, the value of the graph is what we're going to read off. That's going to be the velocity. That's out. The slope of the line connecting the origin and the point. Well, the origin and that point is here and here. The slope of that line has no meaning at all. That's a nonsense answer. The area under the curve. Well, the area under the curve, we said, is the displacement. That's not going to give us the acceleration. So without reading the fourth choice, we know it's the fourth one. Well, let's check. Slope of the tangent at 0.7, choice D.